Hi everyone, this is Mrs. GA, and today we're going to talk about inequalities. Okay, we're going to start by talking about some notation. So there's two different types of notation I'd like you to know with equalities. The first is called set builder notation, and it looks like this. So this is essentially saying your answers are x such that x is greater than 0. So that's kind of how you would read it. So again, this is called set builder notation, but we want to know how to write this in interval notation. So the way that you describe anything where x is greater than 0, you always start with the lower number, so that means your lower number will be 0. If it's everything greater, that means our highest number is just infinity. And then we have to decide if we're going to use brackets or parentheses. So if anything is not included, we're always going to use parentheses, and infinity always gets parentheses as well. So if you have something like this, so you'll see the only difference here is that we have greater than or equal to. So again, we go low to high. So our lowest value will be 0, our highest value will be infinity. However, this time it's greater than or equal to, which means 0 is included, so we do a bracket, but infinity is never included, so we do parentheses. You might also see it written as positive infinity, but it is implied if you don't see the plus sign that it's positive infinity. Okay, here we have everything x such that x is less than 0, so it's everything below 0. So that actually means that our lowest value is going to be negative infinity, our highest value will be 0, and neither are included, so parentheses for both. And if we have all x values such that x is less than or equal to 0, again, our lowest value will be negative infinity, our highest is 0, parentheses and brackets because 0 is included. It says or equal to. You may also see something like this where you have your x values described between two numbers. So this reads all x values such that x is between -3 and 1, including 1. So we can write this pretty easily with interval notation. Our lowest is -3. Our highest value is 1. We don't include -3, but we include -1 because of this line. And last, you may have two separate inequalities, so x such that x is less than -3 or x is greater than 1. So the way you write this is first we're going to describe x is less than -3. So that means it's everything from negative infinity to -3, both parentheses. And the way we do or is this U shape. And then we have x is greater than 1, meaning our lowest value will be 1, our highest is infinity, and both receive parentheses. So you should be familiar with these notations, and make sure you can write any answer in either set builder notation or interval notation. A few extra things to remember about inequalities. If you're graphing your answer on a number line, you will use a closed circle if that value is included. So you would color in your circle if it's on a value, or an open circle if it's not included. So for these, for example, in this problem, I would have an open circle in -3 because it's not included, and a closed circle in 1. And last thing to remember when we're solving, if you ever multiply or divide an inequality by a negative value, you need to make sure to flip the inequality sign. Okay, so now we're going to talk about how to solve different types of inequalities, and we're going to start with solving a pair of simultaneous inequalities like this. So really, we can just use our inverse operations. So I can see if I were trying to isolate x, I would add 1, but instead of adding 1 on both sides, I'm going to actually add 1 on all three sides like this. So this is going to give us 5 is less than or equal to 3x is less than 14. Then we're going to divide everything by 3. And we get 5/3 is less than or equal to x is less than 14/3. So to write this in interval notation, we're going to do bracket 5/3, 14/3, parentheses. And there you have it. Okay, now we're going to try solving a nonlinear inequality, so maybe a quadratic inequality. So to do this, you are going to solve your inequality as an equation. So temporarily pretend that it's an equation and solve for x to find what I like to call the critical points. So then you're going to test values in between your critical points to see if your inequality is greater than or less than 0. So you can either substitute values to check, or you can sketch a graph to see physically if your graph is above or below the x-axis. So I'll show you guys both methods here. So first I'm going to solve this as if it were an equation. So it's a quadratic, so I'll start by factoring. So x minus 2 times x minus 3. So I know if I were solving this as an equation, my answers would be x equals 2 and 3. We're going to treat these as our critical points. So now what I'd like you guys to do is I want you to kind of give yourself different zones that we're going to test. So we have 2 and 3. So we need to test some number here, some number here, and some number here to see if our inequality is actually greater than or less than 0. And here I am going to include closed circles because it is less than or equal to. So let's say we test x equals 0 because that's a value that is less than 2. So I'm essentially just going to eyeball this because all we care about is our answer positive or negative. So if I plug in 0 right here, I have a negative value. So I'm just saying negative. And if I plug in 0 here, I have another negative value. And we know that a negative times a negative gives you a positive. So in this area of our inequality, our graph is greater than 0. Now let's test something in between 2 and 3. So you can test maybe, let's test x equals 2.5. So something in between. So if I plug in 2.5 and I subtract 2, that gives me a positive value. But if I have 2.5 minus 3, that gives me a negative value. We know positive times a negative leaves us with a negative. So I know in between 2 and 3, our inequality is less than 0. It is negative. And now we need to test one more value to the right of 3. So let's test x equals 4. Okay, so if I substitute 4 right here, I get a positive value. If I substitute 4 into my second factor, I get a positive value. And a positive times a positive is a positive. So now we need to answer the question. Our job is to find all the times when this inequality is less than or equal to 0. So we essentially just want the negative value. So I'm going to highlight it here. So it would be everything between and including 2 and 3. So our answer would be bracket 2, 3 with a bracket. So you do need to make sure you're looking at your original problem carefully to see if you want the positive or the negative values. Okay, so now we're going to try solving inequalities with quotients. So here we're going to want to set our inequality to 0 if necessary. And then if we have multiple rational expressions, we're going to combine any rational expressions. And then we're going to find critical points by finding two things. We're going to set our numerator equal to 0, which is essentially solving, and that will give us critical points. But we also want to set our denominator equal to 0 to find our restrictions, which are other critical points. And then we test the values in between like we did in the last example to see if our inequality is positive or negative. All right, so let's try this next example together. So you can see here that our inequality is not set equal to 0. So we're going to start by subtracting 1 from both sides. And our next step is to combine any rational expressions you see. So I'm going to try to combine this rational expression in 1. So I need a common denominator, which means I'm going to rewrite 1 as 1 minus x over 1 minus x. So now I have a common denominator, and I can combine into a single rational expression. In my numerator, I'm going to combine like terms. I have 1 minus 1. X plus x is 2x. Or 1 minus x is greater than or equal to 0. So this is what I'm going to look at now that it's combined and simplified to help me find my critical points. So remember, one way you can find a critical point is by setting your numerator equal to 0. So I have x equals 0 as a critical point. But we also want to find a restriction, so we can set our denominator equal to 0 to find another critical point. And I'll say x cannot equal 1. That's our restriction, and it will affect where we test values. So on our number line, we have 0 and 1. And just to remind us, I'm going to do 0 with a closed circle because they do want when it is greater than or equal to 0. But since 1 is a restriction, I'm always going to have an open circle there because it is undefined for a graph. So now we need to test something in all three zones to see if our inequality is positive or negative. So let's say we test x equals negative 1. So if I substitute x equals negative 1 here, I have negative 2 over 1 minus negative 1, which is 2, which gives me a negative value. So I'll say minus sign. Let's substitute something in between 0 and 1. So maybe we can test x equals 1/2. So as I substitute 1/2 here, I'm left with 1 in my numerator and 1/2 in my denominator, which gives me a positive value. So we really only care if it's positive or negative. And if I test, let's say x equals 2 for my last zone, I have positive 4 on the top and negative 1 on the bottom, which gives me a negative answer. So I can see that anything less than 0, my inequality is negative. Anything between 0 and 1, it's positive. And anything greater than 1, it is negative. So let's see what they're asking us to find. They want to know when our inequality is greater than or equal to 0, so positive. So we see that our answer will be everything between here. So it will be bracket 0 to 1 and with a parenthesis at 1 because 1, remember, was a restriction, so we can't include it in our final answer. Okay, I'm going to pause the video and have you guys try this one on your own. We'll check our answer in just a few seconds. So same general steps, set it equal to 0, combine any rational expressions and simplify. So this is really what we're looking at. So we can see that our critical points here are 0 and 6. Notice I have a closed circle here, but an open circle here because 6 is a restriction. So the values that I tested, I chose to test -1, which gave me a negative solution, because 5 over 7 minus 1, I went into the original equation here. If you test x equals 1, you get a positive solution. From my original inequality, you'd get 7 over 5 minus 1, which is positive. And I tested x equals 7, which gives you a negative solution. Again, I plugged it into my original inequality, but wherever you substitute it, will give you the same result. So again, they're asking for when our inequality is greater than or equal to 0, which is another way of saying positive. So I see it's positive in this zone. So between 0 and 6 and including 0. Again, 6 was a critical point, but it's a restriction, so it's not included in our final answer. All right, we're going to try one last example together. And then I'll have you try another. So here, notice our inequality is not set equal to 0. So I'm going to start by actually subtracting my rational equation to the other side. Just a tip, if you have x alone and it's positive, keep that one where it is and move your fraction. So now I want to combine my two rational expressions, so I need to make a common denominator. And now I can combine it into a single fraction. And I'm also going to distribute out my numerator. So I have x squared minus x minus 2. Okay, and then last I am going to factor out my numerator so I can find my critical point. So x minus 2 times x plus 1 over x minus 1 is less than 0. So here I have multiple critical points. So if I pretended to solve and I set my equation or my numerator equal to 0, I have the critical points -1 and 2. And then I also have the restriction that x cannot equal +1, which will be a critical point for us. So notice that they only want where our inequality is less than 0, which means when I draw out my little number line for my different regions, I'm actually going to use open circles for all three. Okay, so now we're going to start testing some different points to see if our inequality is positive or negative. And when I test it, I'm just going to plug it into these factors just to see if it's positive or negative. So let's try testing x equals -2, something in this realm. So if I plug in -2 here, this factor is negative. If I plug in -2 here, it's still negative. And if I plug in -2 here, it is negative. And we know if you have an odd amount of negatives, our answer is negative. So I'll put a minus sign here. Now let's test something between -1 and +1. I'm going to choose 0. So if I substitute 0 here, I get a negative value. If I substitute it here, I get a positive value. And if I substitute in my denominator, I get a negative value. And we know when we have an even amount of negatives, our result is a positive. So I'm going to put a little plus sign up here. Let's test between 1 and 2. Let's test x equals 1.5. So if I have 1.5 and I'm taking away 2, that's negative. This will be positive. And this will be positive because 1.5 minus 1 will still stay in the positive realm. Here we have an odd amount of negatives, so our result is negative. And lastly, let's test x equals 3. So my first factor, I have a positive, second factor would be positive, and my denominator would be positive. If it's all positive, our result will be positive. Okay, so now we're looking for the region where our inequality is less than 0, which is another way of saying negative. So our answer will be this region and this region. So let's see if we can find a way to describe this in interval notation. For this region, my smallest value is -infinity. My largest value is -1. Neither are included. And then we have another separate area that is our answer. So I'm going to put my little u. And then I want to describe this, everything between 1 and 2. Neither are included, so I use parentheses for both. So there you have it. Okay, at this point I'm going to ask you to pause the video again and give this one a try. Okay, so same general idea, set your inequality to 0, combine and factor. Our critical points will be 4 and 2, and we have another critical point at 2, which is our restriction. So we're testing everything between -2, 2, and 4. So you can see I tested -3, 0, 3, and 5 to see if my value was positive or negative. So here are the zones that I got. We're asked to find when our inequality is less than 0. So it's everything from -infinity to -2 and from 2 to 4. So here's how you write it in interval notation. Okay, so last thing we're going to do is solve absolute value inequalities. So to do this, we are going to essentially create two separate inequalities, one for the positive version of the answer and one for the negative, and then solve those individually. So to keep the positive version, our inequality sign stays the same, but when we go do the negative version, we're going to flip our inequality sign, and then we just solve them each separately. So here's what I mean by that. Here we have absolute value of 3x plus 2 is greater than or equal to 4. So we're going to set up two separate inequalities. 3x plus 2 is greater than or equal to 4. So the positive version stays the same. Notice my absolute values are gone. And then I'm going to have negative 4, and since I'm covering the negative version of this answer, I'm going to flip my inequality sign. And we solve each of these separately. So we have x is greater than or equal to 2/3, or we have x is less than or equal to negative 2. So to write this in interval notation, let's start with this one. X is less than or equal to negative 2, which means everything from negative infinity to negative 2, including negative 2. We'll do our little U symbol, and then everything greater than or equal to 2/3 would be everything from 2/3 to positive infinity. And that's our interval notation answer. Okay, last one. Go ahead and pause the video and give this one a try. Okay, let's check our answer here. So we have the positive version and the negative version with a flipped inequality sign. Solve both separately and then write it in interval notation. So negative infinity to 2 and 2 to positive infinity. All right, that's all for today's video. Thank you so much for watching.